afternoon. Today we want to look at how we can obtain quartiles from the graph, or the graphical method of obtaining the quartiles. We are going to start by looking at the procedure on how we can obtain the quartiles on the graph. Starting with the lower quartile, first of all, what we do is we draw what we call a cumulative frequency table. We start by drawing cumulative frequency table. That is step number one. After drawing the cumulative frequency table, then we obtain 25% of the n observation. 25% of the of the n observation. In this case, n represents the total frequency. So it means we get 25% of the total frequency. So then we look for that observation. The 25% is the same as a quarter of n. So we get a quarter of nth observation. Then that figure, after obtaining it, then we draw a graph now. The graph that we draw is what we call the cumulative frequency graph. Cumulative frequency graph, which is a graph of cumulative frequency against the upper class boundaries. That is to say, cumulative frequency on the vertical axis and then the upper class boundaries on the horizontal axis. Then, so we draw that graph. Then after drawing the graph, step number 4, we now draw a horizontal line through it, or through that value, through the observation that we had got. That is to say 1/4 of 1/4 nth observation, or 25% of nth observation. That figure there, we look for it on the cumulative frequency axis. After getting it, then you draw a horizontal line through it. You draw a horizontal line through it until you meet the curve, what we call the cumulative frequency curve. So at that point where you have met the cumulative frequency curve, then you draw a line also downwards to meet the upper class boundary values, that is on the horizontal axis. So the value on the horizontal, or the value on the class boundaries that you fall on, is what is equal to the lower quartile value. So that is how you estimate the lower quartile value, by using the graphical method. Then we can look at the upper quartile, Q3. How do you obtain Q3, or the upper quartile value graphically? For this one here, you find that the process is almost the same. That is to say, we start by drawing a table also, which table is called the cumulative frequency table. Then after drawing the cumulative frequency table, then you now obtain 75% or 3/4 of the nth observation. That is to say, 75% of the total frequency value. So after obtaining that value, we also look for it on the cumulative frequency axis. On the cumulative frequency axis. That figure there, we also draw a horizontal line through it to meet the curve at a certain point. At the point where that line makes the curve, you draw a line downwards to make a horizontal. The figure on the horizontal, which is an upper class boundary value, gives us the upper quartile truth. So basically, in short form, for the upper quartile, we get 75% of n when we correspond. For the lower quartile, we get 25% of n, and then we correspond. So those are the procedures of finding the lower quartile and then the upper quartile graphically. So we are going to look at an example on how we can perform this. The example is the table below shows the mass measured to the nearest kilogram of 50 bodies. Here is the table of values. So the question says, form a cumulative frequency table and use it to draw a cumulative frequency curve. Then part B, use your curve to estimate the upper and the lower quartiles and hence calculate the interquartile range, the interquartile. So, this is how we carry it out. We are saying the first step is, let's look at the solution on how to go about such a question. So we say that the first thing is we draw a cumulative frequency table. So we are going to start by drawing a cumulative frequency table, which looks like this. So here we have the mass measured in kilograms. Then we have the midpoint. Represented by letter X. Then we have the frequency values represented by letter F. Then we now have what we call the cumulative frequency. Cumulative frequency values represented by CF. From here, then we shall have what we call the class boundaries. Class boundaries. So this is the shape of the table. It looks like that. So we are going to fill in our values. The classes here are from 60 to 64, then 65 to 69, then we have 70 to 74, 75 to 79, we have 80 to 84, and then lastly 85 to 89. Those are the classes. Then from these classes, we are going to obtain what we call the midpoint, represented by letter X. To obtain the midpoint, we add the lower class limit, which is 60, to the upper class limit, which is 64, then we divide by 2. So in this case, we shall have 60 plus 64, we get 124. 124. And 124 divided by 2, we shall find that we get 62. 124 divided by 2, you get 62. Then we write here 62. Then we also get the second midpoint. We add the lower class limit plus upper class limit, then we divide it by 2. So we are having 65 plus 69, we get 134. Then we divide it by what? By 2. So when we divide it by 2, we shall find that we get 67. Using the same procedure, here we find that we shall get 72, here 77, here 82, here 87. So this will be the midpoint values. After that, we now write down the values of frequencies which have been given for us. We have 2, 8, 2, the next figure is 6. This is 6. Then 12, 14. We have 10 and 6. 10 and then lastly 6. These values of frequency are going to help us obtain what we call the cumulative frequency values. The values of cumulative frequency are obtained by accumulating the values of frequency. That is to say, we start by writing the first frequency value, which is 2. Then we add it to the second frequency value. 2 plus 6, we get 8. 8 plus 12, we get 20. 20 plus 14, we get 34. 34 plus 10, we get 44. And 44 plus 6, we get 50. So the last figure here becomes 50. And we shall find that when we add the total frequency, when we add all the values of frequency, 2 plus 6 plus 12 plus 14 plus 10 plus 6, total frequency, which is represented by summation f, is equal to 50. This value here should correspond with the last value of the cumulative frequency. Then we now get the class boundary values. The class boundary values. How do we obtain them? To get them, the class boundary values are obtained from the class limits. These are classes. From the lower class limit and the upper class limit, we can obtain lower class boundary value and the upper class boundary value. Lower class boundary is obtained by subtracting 0.5 from the lower class limit value. That is to say, 60 minus 0.5, we shall have 59.5. To get the upper class boundary value, we add 0.5 to the upper class limit value. So we shall have 64 plus 0.5, giving us 64.5. We go to the next. To get the lower class boundary here, we get 65 minus 0.5. giving us 64.5 to 69 plus 0.5, we get 69.5. The next one here will be 69.5 to 74.5. The next will be 74.5 to 79.5. The next will be 79.5 to 84.5, and the last one will be 84.5 to 89.5, using the same procedure. So generally, this is how we obtain the class boundary values. Class boundary values. So after that, these values are going to be represented graphically. We are going to plot now these values on a graph. So the graph that we plot here is the graph of cumulative frequency against the class boundary values. But these class boundary values, when we are writing them, we consider upper class boundaries. So the lower class boundaries are these figures, while these ones on the right are called the upper class boundaries. So we plot the graph of cumulative frequency against upper class boundaries. So this is how our graph looks like. When plotted on the graph, this is how it looks like. So this is the shape of the graph after plotting them. You find that cumulative frequency should be on the vertical axis, while the upper class boundary values should be on the horizontal. This is the shape of the what? Of the graph. Now, when you look at the horizontal values, we are going to look at, first of all, the scale. What does this scale mean? On the horizontal, we find that our values have started from 59.5. They have not started from 0. Now, the next one is 64.5. So what is the range between 65.5 and 59.5? So you find that to get the range, you will subtract. That is 64.5 minus 59.5. We get 5. So the interval here, or what we call the range there, is 5. But how many divisions are there between the first value and the second value? We can say that there are 10 small squares. 10 small squares. So to get the equivalent of each small square, we divide the range by the number of small squares which are there. We find that our range is 5. So 5 divided by 10, we get 0.5. Meaning that each small box or each small square represents 0.5. That is the horizontal. Coming to the vertical, we find that when we look at the vertical, the range is 10. 20 minus 10, we get 10. And there are 10 divisions between 10 and 20, or 10 divisions between 0 and 10. So, 10 divided by 10, the range divided by the number of small squares there. That is 10 divided by 10, giving us 1. Meaning that each small square is equal to 1. That is the interpretation of the vertical scale. Now, we are going to use the maximum use of these scales to help us determine what we call the lower quartile and the upper quartile. Remember our question was the same: form a cumulative frequency table and use it to draw a cumulative frequency curve. We have formed the table, so we have used it now to obtain a cumulative frequency curve, which you are seeing on the what? On the graph. This is what we call the cumulative frequency curve. Now we are going to use our cumulative frequency curve to determine the lower quartile. Now, to find the lower quartile, from the definition of the lower quartile, we say that it is 25% of the total, of the total frequency values observation. So, lower quartile, which is Q1, the lower quartile, which is Q1, is equal to 25%. 25%, which is 25 out of 100. 25% means 25 out of 100 of the frequency values, total frequency values. Or N, we say the N represents the total frequency. So we shall have 25 out of 100 times N, which N is the what? The frequency value, the total frequency. Whereby we said that the total frequency was what? Was 50. Was 50. So this is 0, we look at with this. And then by 5 once, by 5, 2. So 25 divided by 2, we get 12.5. 12.5. So we are going to look for the 12.5 observation. 12.5 observation. Observation on the cumulative frequency axis. So we go to the cumulative frequency axis, which is this one. Then we look for where 12.5 is. So from here, according to our scale, which we say each small box represents 1 unit. So if this is 10, 10 is here, 0, this is 5, 6, 7, 8, 9, 10 is here. So we are looking for 12.5. This is 11, 12.5 is here. So this one here now, this dots here, you draw a line now through 12.5. And this line will meet the curve at a certain point. Where it meets the curve, you draw another line downwards to represent Q1. So Q1 is here down. So the value of Q1 will now be got by, you use now the horizontal scale. Remember on the horizontal, each small box represents 0.5. So from 69.5 up to where this pointer is, there are how many small boxes? You can say that there are 4 of them. 4 of them times 0.5, we get 2. And 2 plus 69.5, 69.5 plus 2, we are saying 69.5 plus 2, we get 71.5. meaning that our Q1 will equal to 71.5. That is the value of the lower quartile, 71.5, this figure here, when we read it from the graph. So we have already got the lower quartile value. Then we can also obtain the upper quartile value. To get the upper quartile, what we do is, we say the upper quartile is 75% of the total frequency value. 75% is, we can now make it, that is Q3 is equal to 75. 75 So we can put it as is equal to 75%. 75% of n, which is the same as 75 out of 100 times n, where n is 50. Then when we cancel this with this, by 5 ones, by 5 2, we shall have 75 divided by 2. So 75 divided by 2, 75 divided by 2, we find that we get 37.5. 37.5. The observation. So, the 37.5 the observation, we come and look for it also on the cumulative frequency axis. So, we are going to look for where 37.5 is. 30 is here. 31, 32, 33, 34, 35, 36, 37.5. Exactly at that point. Then you correspond or you draw a line to meet the curve. Where it meets the curve, you draw another line downwards. The figure on the class boundary axis that this pointer meets will be the upper quartile, which is 2-3. So in this case, our upper quartile 2-3 will equal to this figure here. How do we read it? From 79.5, there are how many small boxes? 3 small boxes. 3 small boxes or 3 small squares times 0.5. We find that we get 1.5. So this 1.5, you add it to 79.5 plus 79.5. 79.5 plus 1.5. So you find that we get 81, which is 81. So it means our upper quartile, which is 2-3, is equal to 81. Now, after getting the upper quartile value, we can now get what we call the interquartile range. They want us to find the interquartile. So to find the interquartile, the interquartile range is got by Q3 minus Q1, whereby Q3 we got it as 81 minus Q1 we have got it as 71.5, and when we subtract we find that we get 81 minus 71.5, we get 9.5. 9.5. So the 9.5 is what is called the interquartile range. Now, if you are asked to find the semi-interquartile range, you will divide the interquartile range by 2. Because the semi-interquartile range is equal to interquartile range over 2. So that is how we find quartiles graphically. For the second quartile, it is the same as determining the median on the graph, which we looked at last time. So for that reason, therefore, our lesson has ended there.